Okay, here we are with Unit 4, Lesson 1. So in this lesson, we're going to explore the gradient or slope of a line. So the goals here are to be able to draw a line when given the gradient and a point, to find the gradient if you're given 2 points, to determine if 2 points are collinear, so that means if they're on the same line, and to apply the idea of gradient or slope to solve problems connected to parallel and perpendicular lines. So the first step here is to think about the concept of gradient and how we can calculate that. So if you recall from grade 8, 9, and 10, the gradient of a line is the slope or the steepness of the line. So this tells us how steep the line is, and it's a ratio of rise over run. So it's comparing the vertical change in the line to the horizontal change in the line, and that creates a ratio. So when we have a graph to look at, we can easily identify the rise and the run. However, if we don't have a graph, sometimes we're given points, like in this example below, and we need to calculate the slope. So if we look at example A, we're given 2 points, 1, 5, and 2, 8. So to calculate the slope, we're going to use the slope formula. And this is in your formula booklet. And the slope is equal to y2 minus y1 over x2 minus x1. And this is just really a coordinate representation of the rise, which is the difference between the y values, compared to the run, or the difference between the x values. So it's really important to know what values you're substituting into this formula. So when you're labeling your points, if you're labeling one coordinate x1, that gets paired with y1. And if you're labeling the other coordinate x2, that gets paired with y2. So remember that your x's always come first in your coordinate pairs and y second, so it's kind of like alphabetical, and you have to pair the 2 1s together and the 2 2s together. So once you identify your values, you can just calculate the slope. So for us, that's going to be 8 minus 5 over 2 minus 1. And so our slope for the first line is 3. So I'm just going to go ahead and calculate the other slopes as well. So for B, same formula, comparing the rise to the run. And here we're going to have negative 2 minus 4 over 3 minus 0, which is negative 6 over 3, which is negative 2. So far, we have 2 of our slopes. We'll do the other 2. So here, for question C, we get 6 minus 6 over negative 1 minus 2. So that gives us 0 over negative 3. But when you do 0 divided by anything, you just get 0. So the slope of line C is 0. And then for line D, our ratio becomes negative 2 minus 5 over 1 minus 1. So here we're dividing by 0, so we get negative 7 over 0. We can't mathematically divide by 0. So when we end up in a case where we're trying to divide by 0, our slope becomes undefined. So we cannot define that with a value. So that's how you can use coordinate pairs to calculate the slope. And now we'll do the second part of the question, which is to graph the points in each case and connect them with a line. So we'll start with line A, and we'll make that one red. So 1, 5 is here, and 2, 8 is going to be up here. So we connect those with a line. That was a terrible line, so I'll redo that one. On a test, you would, of course, be using a ruler to do this. So there's our line, and our slope, it rises 3 and runs 1, so that confirms that our slope is 3. I'll do the next one in blue, B. So we have 0, 4, and 3, negative 2. So that's going to be here. And then we're going to connect these with a line as well, again, you would use a ruler. And then I'll do the next one in green. So here we get 2, 6, and -1, 6. So here, these connect right across like this. And then the last one, I'll do in black. So there we have 1, 5, which is the same point as we had here, and 1, -2, which is here. And we can connect those points with a line as well. So there we have our 4 lines, which we graphed using the coordinate pairs, and we can actually describe each of these lines. So the first line would be positive slope, or we can also describe this as an increasing line. And if we look at the blue one, that one is decreasing from left to right, so that has a negative slope, which is confirmed with our calculation, and we call that a decreasing line. When we have a line like C, where it goes flat across, that's described as a horizontal line. And that has a slope of 0. And the last one, which is the black one here, is a vertical line. And that has an undefined slope. So it's really important to be able to identify and describe and work with slope. So we just have a little bit more information to go through before the end of this video. So the next part is considering the properties of different types of lines. So when we think about horizontal and vertical lines, a horizontal line, like the green one we saw above, runs parallel to the horizontal axis, so it's parallel to the x-axis. A vertical line, like the black one, runs vertically or parallel to the y-axis, and a horizontal line has a gradient that's equal to 0. So the rise over run is equal to 0. And there's a couple other key things to know. So we also know that vertical lines have an undefined slope. So that's an important one as well. And when we think about relationships between two different lines, if the lines are parallel, then the slopes are equal. So parallel lines have identical slopes. On the flip side, perpendicular lines, their slopes are actually quite different from each other. So the slopes of perpendicular lines are what we call negative reciprocals. So there's a couple things that come into play when we talk about negative reciprocals. So the negative part means that the signs are opposite. So if you have one slope and you're looking for a perpendicular slope, they'll have opposite signs. And the reciprocals are the fractions are flipped. So as an example, if we have a line with an equation of y equals -2x plus 3, the perpendicular line will have an equation of y equals, so the negative reciprocal of -2 is going to be the opposite sign, so it's going to be positive, and we're going to flip the fraction. So -2 can also be written as 2 over 1, so this is going to become positive 1 over 2x. And then the y-intercept could be the same, it could be different. It doesn't actually matter what the y-intercept is unless it's asked specifically in the question. The important thing is that the slopes are negative reciprocals. So hopefully you're now comfortable working with gradient and you can work on the practice questions.